And then we look at the Kubernetes networking and storage, Kubernetes tools, and the ecosystem as a whole. For hands-on demo, I don't think today would be ideal. I have other meetings that I need to prepare for, so you might have to schedule hands-on demo in another day, but we can take Q&A after the lecture. So, all right. So we've been hearing Kubernetes. The simplest meaning for Kubernetes is Kubernetes is an open source platform. So it was initially developed by Google, and now it's being maintained by the Cloud Native Computing Foundation. So, and the actual meaning of Kubernetes is being driven from this bullet point here, but I will still read something out. So Kubernetes is an open source container orchestration engine, and as we know, as I mentioned earlier, it's an open source project. This is currently being managed by the Cloud Native Computing Foundation. And one of the key things we can talk about when it comes to Kubernetes is automation. And automation, that's automate application deployment, scaling application when there is resource demand, maybe in terms of peak hours and also in terms of operations. So, and as you can see, the world of software development has evolved a lot when it comes to application development. We are in this age, we have moved from monolithic application development to microservices. And when it comes to microservices, you have a lot of services that you manage. Some applications, when you talk about the likes of Netflix and Spotify and all these companies have integrated microservices into their software development portfolio. So in order to manage these services, they need a tool that basically can handle all the services, and that is where microservice comes in. So one of the key components of Kubernetes is managing clusters of containers. So this will basically enable high availability. And when you take Netflix, for instance, Netflix is a movie streaming platform. So sometimes you ask yourself, why is that even no matter how slow my internet is, I'm still able to stream Netflix movies. One of the reasons is because they have high availability in terms of the services that they are running on their application, and all thanks to Kubernetes that is able to manage such traffic. And yeah, so the other key feature is the portable across. The Kubernetes is portable across cloud platforms and also on-premise data centers. So it doesn't matter where you run your service, you can run Kubernetes anywhere. All right, so that's just the the definition of Kubernetes. And so one of the key prerequisites to understanding what Kubernetes is being able to understand what Docker is and how Docker works, because the main concept of Kubernetes is to manage containers. And so we know Docker is one of the best container engines in the world, and most software development companies has adopted Docker as their main container tool. So in terms of managing Docker containers, we need a tool that can handle the services, and that's where Kubernetes comes in. Okay, so we'll look at earlier when I spoke about the key component of Kubernetes. We look at why Kubernetes is important. So, and these are the reasons: scaling applications automatically based on demand. So let's take for instance, you have like a streaming platform like Spotify where people listen to a lot of music. Okay, so let's say during the peak days, like let's say 12 or 1, people like kind of like to listen to music. But at that time, people are on like breaks, taking their lunch and all of that. And in order to relax their minds, they are listening to music. And so you can see the surge in traffic at that particular time. And so to avoid this, Netflix has adopted Kubernetes to scale applications automatically during these peak hours. And one of the key importance is healing application by restarting field containers. So you don't when during these peak hours, if any of your pods or containers are not functioning properly, Kubernetes has the ability to manage that by restarting any container that has failed or any pod that is not running properly. And another importance of Kubernetes is load balancing traffic across containers. So with the help of Kubernetes, most of the heavy lifting is done for you by Kubernetes. You don't need to be handling all this traffic loads that is coming in. Kubernetes will automatically handle the traffic and ensure that each and every container gets a fair share of the traffic that is coming in. And all these things is being defined in the Kubernetes deployment manifest file, which we'll be looking at some key examples in our sessions as we move on. And one of the key importance also is enabling declarative configurations where the desired state of the system is specified and Kubernetes ensures that the system reaches that state. So inside the Kubernetes file, one of the things that we have is a replica set, which is basically define the state of your system. So if each application is supposed to have, let's say, 3 ports, Kubernetes, you define the replica set to 3, or maybe let's say you want each application to have like 2 ports. You define a replica set of 2. So in this instance, Kubernetes ensures that the state of the ports are always accurate based on the replica set that you define. So at the end of the day, Kubernetes ensures that the system reaches that state all the time. So in case there is a pod that is not functioning or any pod dies, Kubernetes will automatically restart another pod to ensure that that state is always maintained. All right. So the next thing we'll look at is the Kubernetes architecture. So this is the architectural diagram of the Kubernetes tool. So as you can see, Kubernetes mainly works in a server and a client architecture, or a master and a node architecture. Okay, so basically we have the master node, which handles the nodes, the slaves, or the worker nodes. So the master node is more like the main engine of the Kubernetes application. And then the worker nodes are basically the distributed systems that handles your applications. Okay. So when it comes to the Kubernetes architecture, the master node has certain components. And as you can see from the diagram in this section, we have the control plane. We also have the etcd, the kube API server, the scheduler, and then the controller manager. Now, the control plane is basically the component which includes the API, the Kubernetes API server, the etcd, the scheduler, and then the control manager. So these are the components of the control the control plane, and are typically found on the master node. So as I said earlier on, this is the master node. So these are the components that makes up the master node of the Kubernetes 2. And so we look at the master node. The master node is responsible for the entire Kubernetes cluster. And thus it manages all the activities inside the cluster, which the master node communicates with the worker node. So from this diagram, you see we have the master node, which basically sends information to the worker nodes, and then also receives a response based on the Kube API server, the controller manager, and then the scheduler. So we'll look at this one after the other. Now, what is the main activities of the API server? So in simple terms, after installing the kubectl on the master node, okay, you run commands to create pods. And one of the commands that you can run may be kubectl apply. You raise a flag of the file, and then you state the name of the deployment file. And let's see, an example could be, let's say, dev.yaml, and then that's basically like the name of the Kubernetes dev file for your application. Okay. And so basically when you run this command, what you are doing here is you are sending a message to from the kubectl, you are sending a message to the API server to create that particular pod for you. So the command will get the API server, and then the API server forward it to that component, which will help to create the pod. So in other words, the API server is like an entry point of any Kubernetes task, where the API server follows a hierarchical approach to implement the things that you, the commands that you run. You get it? So if you run a command to delete a pod, that's what this command will be sent to the API server to handle this task, and that is deleting the pod, and then the pod will be what deleted. We look at a few commands that we run on Kubernetes, getting to the end of our lecture. All right. So the other component we look at for the master node is the etcd. So the etcd is like more like a database that stores all the piece of information of the master node, all the configurations of the Kubernetes cluster. So basically, you can talk of the information about the worker node, which is also known as the cluster. So these informations can be like a pod IP, the node, the networking configurations, and many more. So the etcd stores data in key value pairs. That is one of the encryption methods that Kubernetes use to store this data. So that's like in key value pairs. So the data comes from the API server to store in the etcd. All right. And then the next feature or the component of the master node is the controller manager. So as you can see, we have the controller manager here, and what the controller manager does is to collect data or information from the API server of the Kubernetes cluster, like let's say the desired state of the cluster. You remember I mentioned replica set. That's more like the desired state of the cluster. So the controller manager ensures that this information is passed to the API server to ensure that this state is what always maintained. Okay, so the desired state of the cluster, and then decide what to do by sending the instruction to the API server. That's basically the function of the controller manager within the Kubernetes master node. And then the other component that we look at is the scheduler. So the scheduler also has its function that it performs. So basically, when the information is being let's say the API server received the information from the controller manager. So this information that the API server receives. Now the API server notifies the scheduler. Let's say a key example can be you want to increase the number of ports in each application. So let's say from 3, you say, okay, I want the number of ports to increase to 4. So when you run the command to increase this number of port without necessarily going into your Kubernetes manifest file to change this, or just by running the command, the API server will receive this information from the scheduler, the controller manager, and then pass this information to the scheduler. So the scheduler's main function is to perform these tasks that have been assigned to it by the API server. And based on the commands that you receive and the information that is passed from the controller manager. Okay. All right. So let's say I want to give a typical scenario. Let's say let's take a more for instance. So the master node, sorry, the master node more like a mall management. So let's say in a shopping mall, you have a management office that takes care of like everything. That includes like money, finance, facility management, everything that's like people who rent them, like that's basically the job of the master node. Okay. So all coordinated activities within the mall is being managed by the mall management. Okay. So you can talk about the Cube API server, which more like the central control point or the central desk of the mall. And then it's where all requests. So let's say something like somebody wants to open a store. Okay, it has to go through the Cube API server to request. Somebody wants to make payment for rent. That has to go through the Cube API server. So the Cube API server is more like the central control desk that handles all these things before it goes to, let's say, top management. Okay. So the etcd more like the central storage point within the mall. So all records, the mall record, finance record, facility, stock records, all these things are being handled by the etcd. And finally, the Cube controller manager, more like the tax manager. So okay, there are people who cleans the mall. Now the tax manager's duty is to ensure that okay, we have about six staff within the cleaning department. So each and every cleaning staff gets to assign a role to perform within the mall, whether cleaning the people's shop, whether cleaning the washrooms. All these things are being distributed by the tax manager. All right. And also the Cube scheduler, that's more like the let's say handles the periods as which each and every task is being performed. So the scheduler is more like the time manager within the mall. So at the end of the day, if I'm also part of the cleaners in the mall and then I'm being assigned a duty to clean the washrooms, so the time manager ensures that at every 12 o'clock noon, I go and clean the mall. At every 5, I go and clean the washroom. At every 5 p.m. Every day in the mall, I go and clean the washroom. So basically, that is like someone who handles the time at which all these activities are being performed. So that is the job of the scheduler manager or the scheduler within the Kubernetes master node. All right. The other thing we'll look at, so we've looked at the master node and its component. The next thing is to look at the worker node, which forms the main cluster of the Kubernetes 2. So the worker node also has its component, which we can see from here. We have the kubelets, the kube proxy, the ports, And yes, so basically these are the components. So the worker node is the mediator who manages and takes care of the containers and communications within the master node. You get it? So basically, a Kubernetes cluster can have like a multiple worker node to scale resources as and when they are what they are needed. So the worker node contains more like 4 components that helps to manage the containers and communicate with the master node. And the first one that we look at is the kubelet. So the primary component of the kubelet, which we have here, um, is to ensure that the pods are running and they are healthy. So that's the job of the kubelet. So it basically manages and regularly checks whether the pods are running or they are not running. And so in an instance where the kubelet check and a pod is not running, then what it does is to basically inform the controller manager to ensure that there is a new pod that is being restarted. So this information will be received by the controller manager, send it to the API server, and then pass that information on to the scheduler to ensure that that task is what is performed. So basically, if pods are not working properly, the kubelet will create a new pod and then replace it with the previous one, because the failed pod can't really be restarted. Once the pod is failed, it can't be restarted. So in this instance, the IP of the pod might also change once it is restarted. It is replaced. Okay. And so the kubelet get the details related to the pod from the API server. So the API server will get all the details of the failed pod and then pass it on to the new pod that has been created. All right. The other component that we look at is the kube proxy. So this is our kube proxy. So the main function of the kube proxy is to handle all networking configurations of the entire cluster, such as the pod IP. Yes, so the kube proxy takes care of the load balancing, that's the networking aspect, and ensures that routings which comes under networking configurations are being maintained. So kubeproxy will get the information about the port from the API server, which exists on the master node, and then pass it on to ensure that the new port that is being created gets the network configuration that it also desired from the failed port. All right, and then the other component that we look at is the port. So as you can see, we have 3 ports here. So we can say the pod is a very small unit that contains the container. So the pods that you are seeing here, they are um the people, okay, or yes, let me see the people that will give you more understanding. So they are the people that basically manages or runs the container. So every pod contains what? A container that is running within it. So basically, and that is where, so a container is where the application is deployed, and the pods are the people who runs the containers, and every container contains an application. So basically, a pod has a public or a private IP range that distributes the proper IP to the containers, and all these networking and activities happen behind the scenes. All you need to do is to just define everything in a file called a service manifest. We'll look at examples of that in a later slides. All right. And the last one is the container engine. So as you can see, as I said earlier on, containers run in the pod. In the architecture, it wasn't stated, but I just had to add it to it. So the container engine basically provide the runtime environment for the container. So in Kubernetes, the container engine directly interacts with container runtime, which is responsible for creating and managing the containers. So there are lots of container engines present in the markets, but so you can see some key examples like the CRI, there is another one called container, and then we have the rockets, and many more. But I think the most preferred one by engineers nowadays is the Docker. So Docker Container Engine is more suitable for people. I haven't really worked with the CRI or container or the rocket, but for Docker, I have worked with Docker before. So, and I believe that most of us on this call have also worked with Docker before. So, all right. So, yeah, that's just about the worker node. And I'll also use an example of, let's say, I'll also use an example of a store in order to explain the worker node also. So basically, when you take the worker node, okay, so the worker node is more like the store manager. So in each store or the worker node, you have a store manager, which is the kubelet, who ensures that employees who are the pods are working correctly. You get it? So that's basically the distinction between the store manager and then the kubelet. So he's more like the store manager, ensures that all the employees are working well before they get paid. All right. And then the kube proxy, more like the customer service desk. So in Amalitech, when you go to the Accra office, there is this fine lady there who ensures that your everything there is anybody who comes to the office is well taken care of and all of that. So basically, the customer service desk is more like the kube proxy. So it acts like the customer service desk in each of the stores. So each of the ports. And so it basically handles the customer inquiries like network requests. That's I'm talking about the kube proxy, and also direct them to the right employees. So the employees in this instance are the ports. And one of the functions is to ensure that networking rules are maintained for load balancing and routing. All right. And the container runtime basically more like employee trainings, like what we are doing here right now. We are doing training, and so that's what the container runtime does. So your container runtime can be like somebody, a resource personnel that provides training for people and all of that. All right. So in each store, you have employees who are the pods who needs training to perform their tasks, and that is what we are currently doing here right now. Okay, so that's about the Kubernetes architecture diagram. So you can see some definitions of the everything that I've spoken about with regards to the diagram. So we talk about the master node, we talk about the worker node, we also talk about the control plane, and we have key components for each of them, like the API server, the etcd, the scheduler, the controller manager, the worker node, and what have you. All right, so we'll move on to our next slide. So yeah, that's also the component of the master node, which I explained earlier in our diagram. Also the component of the worker nodes. All right, so key Kubernetes components. Yeah, so the pods and containers, I spoke to that with regards to the, yeah, so I was talking about the replica sets. So here we look at the replica set, the deployment, and then services. So these are the one of the key things that you need when it comes to Kubernetes deployment. And like I said in my explanation, the replica set basically maintains the desired state of the pod. And then the deployment file contains all the configurations for the application deployment. And then the service handles all the networking architecture. So replica set ensures that a specified number of pods replicas are running at any given time. If a pod fails, replica set automatically creates new ones to replace it. And then the deployment files. So the deployment provides declarative update to applications managing the replica set, and helps with rolling updates and rollbacks. Okay, so if you deploy Kubernetes application, and then there is an issue, you can basically roll back to the maybe you made an update and the update is causing issues. You also have the tendency to roll back to the previous state of the manifest file. And we have the service which exposes a set of ports as a network service. So Kubernetes service enable communication between different ports with the external world. So this is a typical example of a Kubernetes deployment file. So this is what handles the application deployment. So as you can see, we have the um, API service. Give me a minute. So we have the API version. So this is the structured layout of the Kubernetes file. So we have the manifest file. We have the API version, which these are like standard. They are, you can't change this. They are standard in every application deployment. So we have the kind, which states the name of the deployment file. So basically, the API version and the kind define the resource. And in this stance, it is a deployment. Okay. And then metadata specify the details of the deployment, such as the name of the deployment and then the labels. So as you can see, the name of the deployment here is my app, an example. So in the case of, let's say, AMPs, so instead of my app, you can define the particular service, which is let's take front end. So performance front end pro. So that would be the name of the application. And then the spec or the specification basically define the desired state of the deployment. So I spoke about this in my explanation with regards to the architecture. So this is the specification and then the replica. So here we are defining three. So the desired state of the application or the pods that Kubernetes must maintain all the time is what? Three. In case out of these three, any of the pod dies, Kubernetes must ensure that there's a new pod that is created to maintain this state to three. And then we also have the selector. So the function of the selector is to basically spy which port the replica configuration should be applied with the help of the label. So this label will ensure, the match labels will ensure that the pod name here is the app. So in this case, we are talking about, let's say, any of our AMP service like payroll or something. So that could be the name of the pod. And then we also have a template. So the template describes the pod template and how deployment will use it to create the new pod. So every time there is a new pod that is going to be created, Kubernetes will depend on this template to ensure that the pod, which is my app in this circumstance, is what is being being deployed. Okay, and then I spoke to the labels earlier. So the labels will basically select their particular pod, the pod name that was previously used by the other pod that died. Okay. All right. So we have containers. So containers will list the containers to run within the pod. So maybe this will basically be like the name of the image or something. Okay. So you define the name of the container and then the image. So the image the Docker image that you build, this is where you specify the Docker image that you built. And so under this second, we are using my app image, and then like that's the standard way. But I think there are more flexible ways you can define these, maybe in the environment variables, in order to show the name of the image. You can define environment variables and then call that particular variable in this image name. All right. And yeah, so that's basically about the deployment file. The next file that we look at is the service file. So in my previous explanation, I mentioned the networking aspect of the Kubernetes architecture. And so in the service file, this is where we define all the networking aspects. So in this instance, So the API version and the kind same format. That's defining the resource. So in this case, in this instance, the resource is service. We have the metadata. We specify the name of the service. So the name of the service is this, and then basically the selector. So the selector is the specification specify the exact state which I mentioned earlier. The selector also specify on which of the port configurations will be invoked. And so in this case, when you look at the deployment file, we have the name here as an app. So in this case, the deployment will be invoked on my app, which is the service. And the other component of the manifest file is the ports. So port specify which ports the service will listen on. So you see in when you are defining the Docker image or the Docker file configuration, you state the port. So in terms of the service, you ensure that you so here we have target port. Now this target port is in reference to your Docker file, the port that you define in the Docker file. So this is where so at the end of the day, the networking communication, when you launch the port will reference this port in the Docker file for the container. So that's why we have target port. And then in this instance, we are opening port 80. Now, when you are deploying this application, you ensure that on your cluster service group, all these ports are open. So port 80 and then port 8080. That's the target port for the Docker file, which basically the container port, and then you reference it in the Kubernetes manifest file. The last thing that we'll look at in terms of the file is the kubeconfig. So the kubeconfig basically also handles basically handles the your DBR or secret file, DB secret files configuration and all of that. So the same manifest layout. So you define your API version and the resource type is the config. You cluster the name of the cluster and then the server. So here the server we will be reaching is the API.example.com. So in this case, this can be your Amalitech, how do you call it? The Amalitech URL, what we will use to reach AMPs. And we have the certificate authority. So this handles the SSL configurations, and then the name of the user. So the certificate authority user, all these will be defined in your DB configurations and other stuff. Okay. So the users basically specify the users with the client certificate and then the client key name. And so basically those who will be accessing this are people who have been authorized with the credentials. And then, yeah. So in terms of context specify the cluster. So you can see the cluster name, that's the name of the cluster. And then the namespace. So namespace are used to manage your Kubernetes cluster. So you define a namespace where you deploy all your applications. So if you are making query using kubectl, you always have to state the namespace. So this is done to ensure that your application deployment is not scattered all over the cluster. So once you define a namespace, each and every, when you are applying any or deploying any application, once you flag the namespace, the application will be deploying that namespace. So it helps in organization and management as well. So yes, so these are a bit of explanation on the name. So namespace, logical patterns in a Kubernetes cluster that helps organize and isolate resources. Labels, that's the key value pairs attached to objects like pods or services used to identify and select groups of resources within a namespace. So I think we've spoken about this. Kubernetes simplifies the management of containers application by abstracting the underlying infrastructure and automating tasks like deploying the containers across a cluster, auto scaling containers based on CPU or memory usage. So in terms of auto scaling, we have two types of scaling. We have the horizontal scaling and then vertical scaling. So with horizontal scaling handles resources, so the CPU, memory utilization, and all of that. And vertical scaling, that's basically like adding servers to your nodes once you run out of resources in that instance. But I think the most effective one is the horizontal scaling, which directly deals with the CPU and memory utilization. And in terms of monitoring, so monitor container health and automatically restarting failed containers. So these are Kubernetes in action for you. And so yeah, so these are the scaling and self-healing. So horizontal, I spoke about it earlier. Adjust the number of ports replicate based on the CPU or other metrics. Self-healing, Kubernetes continuously monitor the health of applications. If a port crashes, Kubernetes will replace it automatically without any human intervention. So rolling back and rolling out. So rolling updates ensure that new versions are deployed gradually while maintaining service availability. So you can do updates. You can, in your deployment, Kubernetes deployment file, you can state the roll back and then roll out configurations to ensure that um, service still runs whilst all these things are being performed without any downtime. Okay. So yes, real world use cases. I mentioned Spotify. I mentioned companies like Netflix. So Spotify uses it to manage millions of users, playlists, and music streams. And that's why you can stream Spotify music wherever you are, all because they hack the Kubernetes system and then ensure that people enjoy music all over the world. All you need is just small amount of internet, MPS, and you stream music wherever you find yourself. Airbnb migrated to Kubernetes for flexible scaling and efficient resource utilization. So Google Cloud, Kubernetes underpins Google Kubernetes engine, that's the GKE, one of the leading managed Kubernetes services. Anyway, I don't know, but for me, I think I love AWS more than any other thing in this world. So I don't care whatever Google says. Okay, so Kubernetes networking and storage. I explained the service and then the deployment and the queue config. So service expose a set of ports as a network service. So you talk about ingress. So ingress manage external access to services. So in terms of in Kubernetes, we deploy ingress controller to ensure that external access to the services are being managed. So that's basically under HTTP or HTTPS. But we all know HTTP, what it does, and HTTPS, what it also does. So we just ensure that our clusters are secure. So we always ensure that we deploy HTTPS. Cluster IP, so the default service type for communication within the cluster. So cluster IP basically that's like a local communication between the cluster and load balancer. So now when you look at our Kubernetes diagram, we are deploying a load balancer, which will basically allow us to expose our services to the world from the private, even though they have been deployed in the private subnets. But with the help of the load application load balancer, we automatically provisions an external load balancer for all the services. So through this, we can be able to access the services in a secure way. So we have persistent storage in Kubernetes. So this basically defines how you attach storage to your Kubernetes deployment. So basically, if you are deploying RDS, any external database, usually it's not a good practice to deploy Kubernetes with storage devices. So basically, you always ensure that you isolate your storage device from your Kubernetes deployment. So Kubernetes decouples storage from the pod lifecycle, allowing persistent storage that outlives the. Also, you can talk about the persistent volume. This will more like a physical storage resource defined by an administrator. So you define all these the storage resources. So like password and all the database password and all the database configuration, you define it in the persistent volume. And that's what the Kubernetes pods will use to access storage for the application and all that. And then we also have the persistent volume claims, request for storage by pods, storage class define the different types of storage. So you use storage class to define the different kind of storage that you are attaching to your application deployment, which is either we are using an SSD or HDD now available within the Kubernetes cluster, allowing for dynamic provision of storages. Sorry. All right, so Kubernetes tools and ecosystem HEM. So now think of this, okay, Docker Cube. Now realize that Docker Compose is not able to handle our services in the way we want it. So we need a tool that basically helps us to do some of the heavy lifting through automation. And that's where Kubernetes came. Now that Kubernetes has come, now we also need another tool that simplifies the way we handle the Kubernetes deployment. And that's where Helm comes in. So Helm is basically Kubernetes package manager. So Helm simplifies Kubernetes application deployment by packaging the resources as charts. So these allow users to define, install, and upgrade even the most complex Kubernetes application. So with the help of Helm, we are able to even manage over thousands of microservice applications that are running on Kubernetes because of its simplified way of ensuring that all resources are being packaged in charts. So let's say if you are using something like a vanilla Kubernetes to deploy applications, so you have over millions of services. Let's take a company like Netflix or even Spotify. They run over thousands of services. Do you get it? So at the end of the day, all these services, you have to define a deployment file. You have to define service, account service, all the communication channels or all the deployment files that you need for your application. You have to define them using Kubernetes. That's when you are running a vanilla Kubernetes or you are deploying application using vanilla Kubernetes where you have to take care of all these configurations. But with the help of Helm, all these things have been simplified. So having all applications manifest file, you can just run a Helm install, and then this will basically deploy every single file that you define for your application deployment. And so Helm charts a collection of files describing a related set of Kubernetes resources. So Helm is one of the best tools when you are planning to deploy applications on Kubernetes. It helps simplify your manifest deployment and all that. So these are some key commands that we run on Kubernetes to interact with the API server. So kubectl is the primary command line interface for interacting with Kubernetes clusters, and some essential commands include kubectl get pods. So this will basically list all the running pods. So once you run this command, you get access to all the pods that are running. We also talk about kubectl describe. So this will basically display the detailed information of the pod. So you see the port type, the IP address, every other network configuration, if the port is healthy or not, you see the status of the port, everything. So if you want to see this without using like a monitoring or observability tool, this is the command to write. And then also the last one, you talk about the kubectl or apply. The F dash F is more like the name of that. So you define this command to deploy the resource from a configuration file. So if we want to deploy, let's say we are running a vanilla Kubernetes, and then we want to deploy a deployment file. This is how you define. So kubectl or apply, then the flag F, which simplify the file, and then you state the name. So in this instance, we are going to have something like if technically we want to deploy, let's say a typical Kubernetes, so you say kubectl apply, then dash F, and then the name of the file, let's say dev.yaml. So that's basically how then you hit enter, and basically you run this command to deploy your development application. So yeah, that's an example there. So monitoring tools, for me, I think the best tool that monitoring tools that I've worked with so far, which I still advocate for often, is Prometheus and then Grafana, because these two combinations are advanced. They give you detailed insight into your Kubernetes cluster, CPU usage, any resources, networking, everything. You get to see all these things on a dashboard. You create notifications to Slack, emails, everything from Grafana, and you get to visualize all the tools that have been integrated in your cluster. So Prometheus, a visualization tool that integrate with Prometheus to provide dashboards and graph for better cluster insight. For me, I always go with Prometheus and Grafana because I see it to be even more advanced than CloudWatch. Because in terms of metrics, it's far better than, maybe because I haven't really deployed CloudWatch most often. I don't know. I just don't like the way they handle log management and how we visualize the resource usage in clusters. Anyway, maybe somebody might also like it. So you just have to go with what's best for you and what you are comfortable with. All right, so that brings us to the end of our lecture. Wow, I have a meeting in a few minutes. Meeting has already started, but I'll take a few. So, like I said, we'll find another day to just do a quick demo, and then we can see Kubernetes in real life. Maybe run it locally with Minikube. Yeah. Thank you, and I'll take some few Q&A because I have to join another meeting in a few minutes. So yeah, thank you. Oh, people's hands are already up. Wow. All right, Jerry.
Thank you, Lloyd. So I think I have like two questions. So the first one is concerning the kubeconfig. I think you were talking about the server. There was like a
The what?
server URL there. Maybe you can
Yes,
just
yes.
show. I don't know if you can just show the screen and the slides.
Okay. Yes.
Yeah, so the server there, would it be, I think you were saying it will be the ARMS URL. I'm not sure I
So
was clear on that.
So I think with this, it comes with different. So that is the cluster. So basically, the URL that is handling your cluster application, that would be the URL. You get it? So in this
Okay.
case, the URL for ARMS, we have different URL with different servers, but the main URL that we access ARMS on basically. So that would be like, let's say, where's the URL? I think arms this one. So that's arms dash beta dot armalitech.org. You get it. So that's probably be the
Okay.
URL for the cluster. You get it.
Okay.
Yeah.
I was asking because for some of them, for like a current cluster that I've like connected to, it appears to be like the AWS URL. So it's kind of I don't know how to I don't have it up.
The
Let me see.
AWS URL.
Yeah, so it's like EKS EU Central blah 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 cluster slash the name of the cluster. So I don't know which is which.
So just as I said, so that's the URL that you'll be accessing the cluster on. So you know the cluster
Okay.
is like contains the all the ports that's running your application. You get it?
Okay. Yeah.
Yeah. So that's the URL.
Okay. Sure. And my last question is concerning the persistent volume claims. So
Mm-hmm.
um from like what I've seen or heard, it's like when a single pod has access to a particular persistent volume claim, it's supposed to,
Mm-hmm.
it's kind of like, so if let's say an administrator provisions 1 GB of storage, and then
Mm-hmm.
a pod just needs like 20 MB, but
Mm-hmm.
that pod has the persistent volume claim, does that mean no other pod will be able to, it means no other pod will be able to take up like the rest of the 1 gig that is there, although it just needs like 200 or 20 megabytes? Is that not a waste
Um,
of resources, or there's a,
I don't
maybe
I don't
there's a
think I
more
get
a
your
better
question
way?
from the beginning. I don't think I get
O-
your question from the beginning. Come
Okay,
again.
okay, so my idea of like a persistent volume claim is that if a particular
Mm-hmm.
pod has um has been given that persistent volume claim,
Mm-hmm.
the
A particular port has been given that
the
persistent volume.
persistent volume claim, right?
Mm-hmm.
If let's say the storage resource that it's being, that the PVC is pointing to, is let's say
Mm-hmm.
1 gig, right? But the pod needs
Mm-hmm.
just like 200 megabytes.
Mm-hmm.
The rest of
So
the
yeah. So to answer your question, now in terms of in your Kubernetes manifest file, you define resource usages that each pod
okay,
is supposed to have access to. You get it?
okay,
So
yeah,
even though you have like 1 gig, now you define resource limit that each pod is supposed to have access to, and that's basically
okay,
what the Kubernetes allocate for each of the pod. You get it?
okay,
Yeah.
okay. So even if, okay, I think it's fine. I think I get. Yeah.
Or if you
Thank you.
still have confusion, you can ask. Okay.
No,
That's why we are here to.
I feel like if it has access to it and it's supposed to use that, but you defining the constraints, I think that would solve the problem of it's just taking everything. So I think it's fine. Thank you.
All right. You're
Yeah.
welcome. Any other question? Any other question?
None I see.
Oh,
Thank you, Lloyd, for your time and for your patience.
you're welcome.
Please, the next meeting is waiting for you.
Come again?
The next meeting is waiting for you.
Yes, yes, yes. All right, guys. So Jennifer and I will okay, Jessica and I will
Hey, who is
um
Jennifer?
sorry, I meant to say Jessica. We'll have a meeting later and then try and do some demo um to conclude our lesson for our workshop on K8. So thank you guys for
Okay.
coming. And
Lloyd, hello.
yes, yes, sir.
Yeah, the next session has been scheduled for 11 to 12 tomorrow. So I think we can have the demo at that
All
time.
right. Okay. Okay. That's fine. That's
All
All right.
right.
Thank you, everyone. I have to jump to another meeting.
Have a
I'm
nice
so
day.
sorry. All
All
right. Bye.
right, guys. Thanks for coming. See you tomorrow.
Jessica,
Yes, posting.
am I added to the meeting?
I think so.
Not really.
Oh, then I'm sorry.
And
I added the DevOps team. So if you missed it, then you are not in the DevOps team.
so who to blame? Oh, I'm in the team, by the way. Yeah, I'm in the team. Let me check.